Hello everybody, welcome to this last video tutorial for the Grasshopper series that I've been doing. So for this video tutorial we're going to start exploring what I would say is the final test for you to start taking advantage of what Grasshopper is capable of doing. So what I'm talking about is the concept of generative design. And if you're not familiar with the concept or haven't heard of it, it's basically letting the computer take all the variables that you've created for the model using Grasshopper and ask the software to move those variables and try to test a result to make it more efficient or less efficient. That's the general idea. And I want to emphasize that this is going to be a really brief explanation of what you can do with this concept. So definitely encourage you to read a little bit more, explore. You can find a lot of video tutorials on YouTube as well on the topic. It can get really complex really quickly. So it might take you some time to really fully understand what this idea is all about. But at least to introduce you into what generative design is, there's a tool in Grasshopper that you can use. You come here to the first tab, params or parameters, and you go then to the end part in utilities. You have at the end this set of tool that the main name is Galapagos, and you get this little pink component, and that's all you need to start exploring generative design. Again, this is going to be just the introduction. Generative design going to really complex aspects of mathematics and algorithms, but you can do a few tests, really interesting tests with this component, and that's what we're going to explore in this video tutorial. So the first thing that you're gonna need to keep in mind and understand quite clearly is how to organize the results that you got from the previous video tutorial that it was about Ladybug and making an analysis. The one that we made in the video tutorial was direct sunlight. So just determine how many hours of direct sunlight this building is getting. And just to recap of what we had before is a basic shape that has a variable that rotates the entire building and a variable and a slider that rotates each one of the floors. Now, something that you would usually do to optimize a model like this, in this case, for example, I want to make this building to have the less amount of direct sun in the facade. So you would have to start rotating until you get the result. Just again, you can see in here that this is the amount of hours. Yellow is 10 hours in this period of time that I analyze, all going back into the previous video tutorials. I determined that it's going to be in April 21st and to do an analysis in these different hours, 8 a.m. to 5. So each one of these is going to be one of this sun, and that is what this building is taking as an analysis. It's taking the average of that day to then represent all of this. Now again, every time that I start rotating this, I would have the option to just graphically start to find a position that I would be happy with, but that would be quite random and you won't be able to actually determine if it's the most efficient shape. Might be looking interesting and might be possible that it's a good one. You start to see that there's a lot of blue, so not much direct sun. But it might be that this is too much sun as well. And in the results, if you try to understand the results on your own, just making a paneling here, I go into Ladybug daylight component, and the results, it's simply showing that each one of these squares in the grid of the surface that this component is creating is going to get assigned the amount of hours that it has for direct sun. That's the way that Ladybug start to create the analysis for that shape. You can add a tag, that's what I did in here, and you can see that if I come closer, each one of those squares has a number, different numbers. This corresponds to the analysis of the average of how many sun hours of sunlight is getting, and that's the numbers in here. And as you can see, there's too many. There's almost 3,000 results, and it'll be really difficult for you to actually do it on your own to check what is the best result. So that's when generative design and computational design is the best option to optimize things in a really quick way. So for Galapagos, what you would do is to first have a general understanding of what's going to happen, is that I'm taking all of these results, I'm simply organizing those results so I can determine the zero amount of hours has all of these blue squares. It's going to be 0. So there's 2088 zero numbers that represent the blue, and 10 is going to be, as you can see here, 10 is yellow. So there's going to be 187 squares that has the 10 hours of direct sunlight. So when I have that result, I counted, Grasshopper helps me count all of those results. I can then tell Galapagos to change these sliders, so to start moving all of these sliders to all of the different positions that it has from in the building rotation from 0 to 90 degrees, and the floor rotations, each one of these rotating from 0 to 90 degrees as well. And Galapagos is going to start moving this slider automatically, and it will record all of these results. So I'm going to tell it to test these results, 9 and 10, to get an average that is going to be the number of squares with those numbers. So it starts to get a little bit confusing, but just to get an idea, I'm trying to find the minimum amount of 10 hours of direct sunlight in the facade. Galapagos is going to move those sliders until it finds the smaller number. So I'm going to quickly do a test, and just to show you how you connect things to Galapagos is you first have genom, and that you connect to, and something to keep in mind is that you always go from the Galapagos component into the rest of the components. Genome is the sliders, as I mentioned. Galapagos is going to move those sliders. So you go there. I want to change the rotation of the building. Going back in here, and then come back here, pressing Shift to add multiple ones. I wanted to rotate the angle of the flows as well. You can see that it makes that red square for the sliders that Galapagos is going to change. And now I want to Galapagos, again from Galapagos to the results, have here the average from those two, so I can tell Galapagos can know the minimum result that it needs to make. So just to make it visual, right now I have having the floor rotation between 0 and building rotation in 0 and floor rotation in 0. I have an average of 146 direct sun hours in the facade. If I manually move this, let's make it something that it looks a little bit better. So let's do it something like that. We can find that the average is going to be 107. And I could go manually trying to find the best position for those flows until I'm happy, as I mentioned. But it would take a long time to test all of those positions and then go back into the results and see if this it is better. That one is better. Has a less amount of hours. But when I go into Galapagos, and really quickly I'm gonna come back here to explain more in a moment, but really quickly just to see what happens is that it automatically starts to change those sliders and it's gonna change the results. So you can see that the maximum amount of hours, that is 10, they have registered, starts to jump up and down, and Galapagos will start to determine which one is the best result. And then it's going to give you a list of all of the possible results, and even finding positions that have the same result, but it gives you a different shape. So you can find different possible design opportunities that have the most optimal result. This is what generative design is all about, kind of testing design possibilities and getting the best result all the time. And these results take some time. This is going to rotate all those floors and the building to all the possibilities, so it takes some time. I'm just going to stop for now just to show you in more detail what you need to do to be able to get these results. But this is just to first give you an idea of what happens. Okay, I'm just going to stop there. And as you can see in that really quick test, I already have all of these results. That goes from the minimum to be to, and I can change that. This is going to give me the minimum amount of sun hours, that is 52 as the average, and it also gives me the maximum. So it could be as well that maybe what you're trying to design is surface in a roof, or there's a building that it has a big surface that is dedicated to collect solar energy, and well, this would be the opposite case of what I'm doing, what I was planning before. And in that case, for a solar panel, you're gonna need to get the maximum amount of direct sunlight in the surface. So in that case, I would select the maximum amount of direct sunlight. So as you can see, minimum and maximum is a fitness test, and you can use it for different situations. You have to be creative to find ways in which you can use this tool. Okay, gonna close that up and start to explain how can you achieve this, because it gets a little bit confusing. It's gonna take you some time. I really recommend for you to try first to follow along, but then go back into each one of the components and try to understand exactly how they work. I'm gonna start first with trying to organize the list, which is something that I would say is the most important part, because if you don't give the right results, you're not gonna get a good design opportunities. So organizing that list of results is gonna be the first thing to do. Now I'm just gonna clean the image so it's not that noisy, and just gonna work with the data. So again, just to visualize, you get results from this ladybug daylight analysis. If you go to ladybug, you have a few analyses. This one is direct sun, as the previous video tutorial, and the result is the amount of hours that each one of these squares get. Now to organize that, so I can easily tell which one is 10 hours, which one is 0 hours, you need to sort that list. Now, I'm going to explain first how to sort a list with this example. So I have here a list, and you can find sort list here in sets, which actually to organize a list of numbers and find out how many of this, for example, 2, how many 2's are repeated in here. That is going to be 2 hours of direct sunlight. Is all here in sets. The first one is going to be sort list, which is right here, sort list, which is this one that I'm going to explain. And the rest that I'm going to use are sets, which are in here, which are basically trying to make this might help to understand more. Just gonna quickly draw. All of those sets are basically the exercise of finding common denominators between things. Now, first, let's try to sort a list and understand what the component is capable of doing. So I just made a random list. You can start doing this as well, just making a panel, which is panel here, or you can double click, make quotation marks, and that gives you a panel. Then I make a random list of a few elements. Click outside, right click, multi-line data. That's how I created a list. And as you can see, the sort list component, what it makes is following the K, which hovering over it says list of sortable keys, simply the list that you want to sort out. And it goes into taking each one of these and make it into the correct order. 1, 2, 5, 5, 8. 1, 2, 5, 5, 8. But you also have in that component this option, that is the A for value A as list, and is going to take an optional list and reorder things following the same order that you have here at the top. It's going to be a little bit confusing here, and you might wonder why would you like to do that, and it actually comes quite handy for the next part. But for now, let's try to understand exactly what it does. I'm gonna take, let's try that out again. Oops. Okay, one more time. Let's take this one out. It's easier for me to draw. So, what that second part, the A to A list does, is that actually is connected wrong. There you go. Here we go. Now, what it does. So the first part is quite logical. It's just sorting this in ascending option. So sorry, descending. So 1 goes to be the first one. Then it follows 2. Quite logical, nothing weird about that. Then 5, then 5, and finally 8. And now what 8 does is going to take this same order in which all of these start to get organized and follows the same one. So I'm just going to erase all of this and we do one by one. So we know that 1 is going to go to the first one. So you can also follow, if maybe it's more comfortable for you, following the index. So 1 goes to 0 and it makes the same thing in here. So 1 goes to 0. It just follows the same pattern that it takes from the top to organize that list and organize the second list. So then you find 2, and 2 goes as the second one. So index 3 goes to index 1. We take index 3 and it goes to index 1. And it's going to do the same thing. After that, it goes 5, which is index 2 to index 2. So index 2 to index 2. And you actually see that this one is actually not working correctly. And it's just to keep in mind that these two, because it's the same number, it might switch between those two. And it's simply to understand that Grasshopper tries to follow the list. So because the previous number that it did, it was this 2, it's actually going to take first this one. So it goes from the 2, it's going to take the next one. So index 4, go to the index 2. So now index 4 goes to, oh, I deleted the wrong one. Index 4 goes to index 2. Then tries to find the next one, 5 to 3, which is index 2 to index 3, index 2 to index 3, and finally 8, which goes index 0 to index 4, index 0 to index 4. A little bit strange, a little bit confusing, and you might wonder, why would you like to do that? And definitely suggest you to take this component, make a few lists, try to connect and see how it's organizing things. Because now, what I want to show you here is how would you take this list and find out how many of that number, let's say 8, how many 8s are in this list, which is basically where we're trying to find in here. How many 2 hours of sunlight are in this building? How many 10s, how many 0s, how many 5, how many hours each one of these faces have. So basically, I'm just reducing here the example, and I want to count how many 8s are in this list, how many 1s, how many 5, and to do that, you go here, you need to use these tools, that is sets. And the first one that we're going to use is called create set. And what that component does is, just connecting this first list, we see that it's going to tell you first a set of all the distinctive values in L. So basically it's going to start counting the numbers. It says 8, okay, we have 8, we have 1, 1, 5, 5, 8. You already had counted 8, so it's just going to skip. Then 2, 2, 1, already repeated, so it skips. 8, already repeated, it skips. And 5, because it's repeated, it skips. That's how this list is created. Just finding out the unique elements that you have. And after that, this M, what it does is it's going to tell you the index of those numbers. So, and it's going to take you some time. Definitely try to repeat the same exercise with a few different lists, with a few different numbers, see how everything is getting organized. So for you to fully understand, but just following along, is in this case, 8 is 0. So the index is 0. It's finding out the index of those elements. 1, the index for 1 in here is 1, so it shows 1. 5 is 2, 2, 2 matches. Now we have a repeated number, so we see 8. Following along, 8 is actually the first one, so it's 0. That's why you see 0. The index in here is 0. So now you know that every number in here is going to be the index for this one. So I know that 0 means that it's 8, and 6 is going to match with 6. And it's all about trying to organize the list in a way that you can tell Grasshopper which element it is, because Grasshopper only understands index and what element is inside that index. So it's going to take you some time to understand how this list works, and I suggest you to go back and watch the different video tutorials, previous video tutorials that explain a little bit more of list and how lists work, and how trees as well work, because that makes it a little bit more confusing. But it's all about that, paying attention to the index, that is the numbers on the left, that is always going to be in a sequence 0, 1, 2, 3, 4, 5, and the elements of that index. So now we know that each one of these index 0 matches one of these, and using this component that is called member index, I can take all of these numbers and is asked for the set to operate, and then is asking for the numbers to match, and finally just counts how many of those numbers you can find. So it's basically gonna say that you have 3 8s, 2 1s, 2 5, and 1 2. We can count here. It's going back. It says we have 3 8s, 1, 2, 3. That's correct. 2 1s. So 1 here, 1, 2 1s. That's correct as well. 5. It says that there's 2 5, 2 5, and 5. That's correct as well. And finally 2 says that we have 1 2s, and there is 1. So it's definitely correct. That is what these two components will help you to find out how many elements you have repeated in one list, as you can see. But now I want to organize this list. That's when sort list comes back again. And what I want to do is to find out not to see this list in this way, because it's telling me that 8, which is 8 hours of sunlight, is at the top. But I wanted to make it organize it that the maximum is at the end and the minimum is at the top, just to keep things more organized. And you can sort that out in here. So I can take then this list, which is organized. Let me change this one out. 8152, which is actually that was that one at the top. And let's leave this one in here. So this one is the same as. I'm gonna tell it to reorganize this, so the maximum amount of hours is at the end and the minimum at the top, like you see in here. 1 2 5 8, simply organizing this list. And from there, now what I want to do is to make this count to be organized in the same way. So 8 that went to the end is going to match this one, that is 3. So this 3 needs to go to the end as well. And that's when this A comes handy. That we have two different lists that we want to match correctly. And it's simply 8 is the biggest one number. I want that, and this 3, the count of how many 8s go to the end, and this one to come to the top. So now we have that 1 hours of sunlight, we have 2 elements, 2 of the grid, and 2 hours is only 1, 5 hours is 2, and 8 hours is 3. So now from that I can take a list item element, take this list and say that I want to take the last number, so item 3. So I always get the result. I'm going to take the panel of the maximum amount of hours. So in this case I made 8, but From the full analysis, we have maximum of 10. And it doesn't matter how many times it rotates, how many times it changes the list. These 3 components will let you keep this order always working, so you always have the minimum amount of hours at the top, the minimum amount of hours at the top and the count at the top, and the maximum amount of hours of sunlight in the bottom, as well as the count of those hours. And again, I know this might be confusing, and definitely recommend you to do this little exercise to organize list a few times to fully understand what it is. I can tell you, I myself, even if I've done it a few times, I still get confused sometimes, because it's just a strange way to do things. But it's really rewarding at the end when you just have to do it once. You know that it works, and it doesn't matter what list you connect, it's always gonna organize it properly, and you can take the results. Okay, now following along to the exercise, now we're using the proper results, and actually we can do this so you can see what happens if I connect the actual list. It's simply saying that now have actually the index 3, so it's telling me how many of the 3 are, how many 3 hours do you have. But I want the 10, so I would just go into 10, and I get that there's 267 yellow rectangles. That's all it means. And what I did to make the actual test is exactly the same. I use the exact same components: create set, member index, sort list. I got the list just organized, so I know 0 hours of sunlight, there's 2,280, which is how many of those blue squares are in the building, or how many blue of those results. And I know that 10 hours of sunlight is going to be the yellow, and it's 267. And if we come back here to rotate this building, let's rotate it here, something strange like that, and you start to see that it changed again depending on that result. All following along from the previous video tutorials. Actually, I might do this, I forgot, so you can see a little bit better what components I'm using, so you can try to connect this following along. So I use create list, I connect all of the results to that component. After that, I use the component member index that is going to find out all of the elements in the list, what index they have, and then I'm going to sort that list so I get the organized results. From that, I use this too, and I actually didn't use the final result, which is 10 hours, as the one that I'm testing, because I find out that there is a few times that the building can get into a point that none of the faces, none of the grid squares received more than 9 hours of sunlight. So what I did, and this is something that the more complex the analysis that you're doing, the more math you're going to need to do. In this case, it's just the average. I'm taking the average amount of hours between 9 and 10 hours, which is the addition of those two numbers, those two results, divided by the amount of numbers. In this case, it's just 2. So, but I decided to add in this exercise list length, so you get an idea of if you have more than 2 results, you can make actually the average of all of this and maybe do an analysis that way. So you just have to plug in all of those elements. For example, if I have a third item list, Which is taking the index, let's say 8 this time. And I add this one to the relay, which relays you can get any relay you can create by double clicking any line. If you click any line, you get that relay. That relay, what allows you is to connect multiple things. And then you use the component list length, which is going to let you count how many elements are in that list. So in this case, you can see, let's create a panel. And you can see that it says 3 elements. If I disconnect this one, it's going to be 2. If I add more to those, it's going to be pressing always shift to add more elements, 4. So let's delete this one. And if you want to make the average of all of these elements, you can actually connect that one to list length. And you can see it says 11 elements is 0 to 10, so 10 elements plus 0, 11. And that's how you find the average. That's one way to go. Okay, after that, use the division to find the average, and I plug in number component, empty number component. So just to keep things a little bit more organized, and actually Galapagos doesn't like to go sometimes to these results, so I prefer to use an independent component. And it's simply the last result, 105, that is the average of those two numbers. So now just keeping an eye on that number, that we have 105 now. But if I rotate that building, change the shape, now the result is going to be different. Actually, didn't change it that much. Let's make it a little more aggressive. Probably 0. Now we have 146 as the average sunlight that is receiving between 9 and 10 hours. After that, remember, genome is for the sliders. It only receives the sliders. That is going to be the variables that you're going to change in the shape. And the fitness is the result that you're going to test. The best way to see it is testing a result and make it to find the minimum and maximum amount in that number. All right, after that, you just double click Galapagos. You can select in here to organize the list, minimize and maximize. So in this case, I want minimize to be the result that I get. So it's always going to test to get the minimum amount of hours, and that result is always going to be at the top. Now, just to let you know a little bit more how this works, definitely not going to explain in here all of these options, but definitely recommend you to check all of these links. That is going to give you more information. Like I said, this is just an introduction. There's a lot of information to understand how generative design or evolutionary design works. This is the same concept. So for now, just leave this as the default. Nothing to change. You can just switch between minimize and maximize depending on what you want to get. In this case, minimize. Then you click here at top solver. And between these options, you want to use this. That is the evolutionary solver. This second one is for a different set of options. And again, recommend you to check more information between all of these to understand better. And then on this side, you have different options to display things in the Rhino viewport. So you can say that all the information that analyzes in here is going to be shown in the viewport. I don't recommend that too much because it depends on the power, how powerful your computer is to see if it can run all of those changes. And because we're using Ladybug already, takes quite a hit in the computer processing power. So the next option is to change the shape to the best result. That's the second one in the middle. And finally, the last one is simply is not gonna display anything in here. It's just gonna run the numbers. It's all about the numbers inside here. So it's gonna run really quickly through a lot of options, and then you can pick individually what results you want. I like keeping it in here as the second option in the middle to see the best results, so I can see a few changes and see what's going on to decide if that's good enough to stop the solver. That once you click this start solver, it's gonna keep running indefinitely until you run out of possibilities, which you can see there's a lot of them between those two sliders, moving all of those between all of those the numbers. And finally, just about nothing special about that little icon at the end. All right, now finally, you just click start solver, and you can start to see how the building starts to rotate. I can show you again. Let me move this here so you can see what exactly is happening. So Galapagos is literally moving those sliders and testing all of the possibilities that you can get against all against the result that you get from all of these sun hours that you organize before. And it's simply organizing all of the possibilities in one list that you start to get after a few seconds. The first few seconds is going to be running internally. That's the way that is made. And after a few seconds, it starts to show. So don't worry if at the beginning it doesn't show anything. It takes a few seconds, maybe 1 or 2 minimum minutes as maximum, before it starts to show all of the results. And after that, you slowly see how this number starts to get smaller and try to find the smaller and smaller. And a lot of times in this case, it's going to happen that a lot of those results is going to be the same number that I run the test before is 45 as the average of average amount of hours of sunlight, and it just finds a lot of solutions that is the same 45, but you can see how having multiple solutions for the same amount of sunlight hours could come as well handy. I'll show you just in a second. And just to let you know, this graph at the bottom explain a little bit better what generative or evolutionary design, how it works. It gets really complex. For you to have a general idea of what it is, try to think of literally the evolution theory and how through generations you start to get improvements in correlation with the variables that you find in the ecosystems. So as an example, you have the evolution of the human being that finds that it adapts to certain environmental situations, and the next generation gets better to, let's say, resist cold weather, or maybe it resists people from the desert develops different type of genetic conditions in the body, and little by little each generation gets better to assimilate those environmental conditions. It can get a little bit really confusing, and it goes really deep into how evolution goes. It's literally like trying to create the evolution of that building to get better and better. So again, this is just the introduction, and there's a lot of information to go through. This is a really basic exercise. You can get into really complex stuff. And when it comes now to sustainability and net zero goals that the world is getting into, all of these techniques come more and more handy, because to achieve those complex sustainability situations, you need to compare a lot of variables, and to achieve net zero buildings, you need to always test different conditions as sunlight, radiation, energy consumption, wind, strength, structural resistance, even money and budget. You can all put that, all that data, you can place it into Grasshopper and start to compare it to achieve better, more efficient results. And technology, computational design, all of these techniques that you can use will help you to test the greatest amount of possibilities, comparing all of that data. Trying to do that manually, as you saw, we had already around 3,000 results, and that was just for this for one day. So try to imagine now trying to make a study that takes a full year, how much information is going to be and how long it would take to manually try to test all of those options. So using computational design, you can quickly take advantage of the computers and computational power and run all that information, compare it against something else, and find the best solution. That's what generative design is all about, and that's what the full potential of Grasshopper comes into fruition. Right, this test, like I say, it can run for a long time, so I'm just gonna stop it for now. I just want to show, you can see these plus signs. This is when it found one of the best solutions, but just keep in mind that as an evolution situation, that best result is going to keep going until it finds a better one. So you can see that 45.5 is always in those results. You can scroll just by clicking and dragging. You can get all of the results, and you're going to get repeated results. Like I said, 45.5. It's exactly the same because it's simply that 45.5 is moving along the evolution line. And just when you click one of those, you can click here reinstate, and it's simply going to change the geometry into that result here, because 45.5 is going to be the same result in all of these options. You can actually go to the last one and start checking all of the results. So for 46, let's reinstate. Nothing's changed much. 40, let's try 95. Oop. It seems, oh, I actually didn't stop the solver. You need to first stop the solver to start showing the results. I was wondering why it wasn't working. So let's try again. Click that one, reinstate. Yep. Click one. Yeah, just start to see how the building starts to rotate. You even have 246 results, and you can see that it's actually different. It rotates a little bit to the side, and even if it has the same amount of sunlight hours, you can see how you can now be sure of using different shapes of the building and having the most efficient result. So you can decide between 46 hours of sunlight as an average in that facade and keeping it straight, or maybe the same amount of daylight sunlight hours, but it starts to create a different shape. And now you can be sure that it has an efficient result. We can keep going and see. Maybe you decide that it actually can be a little bit more than that amount of 46 hours. And you can see now 94 hours takes even shapes like this, 96, 98. And you can start deciding which shape better correlates to the design that you want. And you have now a list of results that you can use. If you even try to select all of this, you can test a few more and see what it is. Sometimes it's really a slight change in the rotation, and you see that the amount of hours can change drastically. Let's try 64. And you can start trying to decide what works best, and it's still correlating all the time with the data, the sunlight data. So that's how you start to take advantage of Grasshopper and computational design. Something that I forgot to mention actually is these 3 components at the end. That component that is called data recorder, you can find it by typing recorder. it's simply going to take all of the information that Galapagos is going to change, so you can take it after, because once you close Galapagos, it's going to reset all the information. You won't see those again. So when you close, you won't be able to get those results unless you record those. So it's important, before you run Galapagos, create recorder, that's a recorder, and simply connect to this result, and the other ones is going to be the sliders. And now you can use the same sorting group in here, like you did in here for this, just to sort all of these results. And then you can find the index of these options for these ones. It would be a task of organizing that list again, so you can find the actual results. So you can go through all of those. And I probably make an extra video tutorial in the future to show how to organize that, and how to maybe display all of those results as part of graphical presentation, like a panel to show results. But for now, try to see and just try to test the best results that you can get. The important part, as I said before, try to learn how to organize the information, because it's going to be all about understanding the results, the information that you get from this analysis and any analysis that you do in Ladybug. That again, you have a lot of them. Ladybug on itself has direct sun hours, radiation, has visibility, has a solar envelope, and view from sun, a few other things. But you also have things like if you go to Honeybee, you have some extra analysis options. In this section, you have more in Honeybee energy consumption that uses Open Plus. And even if you go into, let me actually open this up better. You have Radiance as well, more analysis, and Dragonfly is going to take more analysis. Definitely recommend you, as I told you in the previous video tutorials for Ladybug, there's a lot of analysis that you can do with those tools, and a lot of information in the web page. So go into ladybug.tools and you're going to find a lot of possible scenarios that you can run and test. But the logic is going to be the same. You do the analysis that you get from all the information, the Ladybug location information. It's always going to be the same. Vectors, altitude, azimuth, all of this is pretty much the same. And then the logic is understanding the results that you get, the information that you get, organizing that result, so you can then ask Galapagos to change the sliders to test the result. That's the logic of it. All of these components have the same logic. Okay, I would say that's it for this video. I know it's a lot to take in. You can find this file attached to the video tutorial. So you can open it up, try to see all of the components, and try to follow along, just testing which one of these components what it's doing. Always recommend you to create a panel and connect what you have before and what happened after, to see how the data is moving along the graph. So go into that file, try to test it out, but more than anything, recommend you to just follow along, go back in the video and try to follow along as I do it. So you do it on your own, and then try to go back and try to do it on yourself, on your own, by yourself, without trying to look at the video. That's something that I do, that I would recommend you to do, so you can test yourself and force yourself to really understand how all the information is moving along the graph, because it takes some time, it takes repetition, it takes some practice to really understand, especially exercises like this. do something random that is easy for you to follow along, and do it a few times until you finally understand how it works. The logic is always the same, matching the information, how it moves from one side to another. It's always the same. Right, thank you so much for joining these video tutorials. Hope you enjoy them, and I hope I'll see you around in a future video. Bye.